Hello, everyone. Good afternoon. I believe that you can hear me, so it's a pleasure to be here at the OCX experience. And today I'm going to talk about a vector database, a new search paradigm, and just before we start, just talking about that, in the past years we have been through a new technology which is called artificial intelligence, and this is the hype of the moment, and everybody's talking about that. Let's say that everyone wants to get updates about that. Every company wants to have artificial intelligence on their backgrounds, and this talk is about one of the cores of how an artificial intelligence application works, which is using vector database. So before we start, here at the audience, I would like to know if is there anyone using any artificial intelligence tool or any application like GitHub Copilot or something like that? Does anyone is using that? Oh, great. Nice, good to see that some people just raised their hands about that, and this is good. No, I use GitHub Copilot every day, and it really helps me, and also ChatGPT. It's also helping me a lot with that. And I just knowing more about you. Who works with a software engineer here at the office? Oh, great. Anyone is working at the data architecture engineer as a data engineers? Oh, good to see that. So think about that. I also would like to ask, maybe this is not only about data architecture, but it's also about data modeling. Anyone has any problem when you are there trying to find the best data modeling for your application, or suffering with a problem related to that? Anyone suffers with data modeling on your team or your own company? Oh, good. So to start our talk, and before we jump into the vector database, I just would like to talk about some of the challenges that we have when we are working with data modeling. And so, talking about that, one of the biggest problems that we have nowadays is that we have a lot of data. I know how much of you works with distributed systems like microservices or let's say distributed monoliths. But one of the challenges that we have today is about how do we aggregate multiple data sets. So think about a distributed architecture. You have, I don't know, maybe 10 microservices, 100 microservices, 1,000 microservices. Each of them has their own database. How we are going to aggregate these different data sets and be able to retrieve one API that will be shown into a dashboard for our clients. So this is one of the biggest challenges that we can have today. Also, when we work with big data or any other thing, we always want to understand how we are going to get our data sets together and retrieve something that will be meaningful for our clients. And not only that, there is also a second challenge that I would like to highlight. That is about the data quality. So data quality is all about how trustable is our data and how we can provide it to our clients and show them to to our clients and how this data can be used. So it's not so easy. So sometimes it's hard to get the most recent data updated from from all the data sets that we need to aggregate, and also it's not easy to get it updated. So data quality is one of the problems that we have today. And I would like to highlight the third point, the third challenge that I believe we are under the hood of the data modeling, which is working with non-structured data. Does anyone here work with non-structured data at your job or at your work? Anyone? Anyone knows what's that? What can be this kind of data related? Oh, good. So this is what I would like to highlight and go a little bit deeper on it. So think about what is a non-structured data. So a non-structured data is basically an image, an audio, and a video. So let's think about that. Nowadays when we are on the internet and we do some research at Google, we have the possibility to get some text from it, or let's say a structured data that we can retrieve from it, but also we can just try to find some images, videos, or audios. And when we take a look at the whole internet, there is one interesting fact about non-structured data that this kind of data represents more than 80% of the data in the whole internet. So let's think about artificial intelligence. So we have ChatGPT and all the vendors that has all the data related to it and retrieve something to us. How they how they are working with data if more than 80% of the data at the marketing nowadays are non-structured data. So this is one of the biggest challenges that we have when we talk about artificial intelligence. So in the very beginning, this was the biggest challenge: how we are going to process an images, an audio, and a video at the same time, and be able to get one answer from our large language model to to it. So when you think about artificial intelligence, how how does it works with non-structured data? I mean, it's easy to process a structured data, so we have lots of mechanisms that can be used to process that. But what about artificial intelligence? I don't know if anyone has ever seen this image, but this image is from the GitHub blog. If you can take a look below, there's the link for the article. But this image represents what is behind artificial intelligence application. And as you can see, artificial intelligence is not only about large language models or Hagger algorithms or these things that usually people are talking about. And also not only about prompting an engineer. So as you can see, there are lots of components in artificial intelligence architecture. And this is interesting because when I started studying more things related to artificial intelligence, I got this argument and I told to myself, hey, this is amazing. There is one architecture behind it. So let's start to study each of these components and try to understand a little bit more about this totally new ecosystem. And then the first thing that caused my attention was later to how we how the data modeling for artificial intelligence works. So I just take a look at it, and you can see that there is something named embedding module, and the other thing named data filter. Also, there is the initial prompt, which is something that usually people talks about, and also there is something pretty interesting that's the vector database. As you can see on the image, a vector database is a way to query embedding methods to vector database embeddings. Snippets pulled from vector database based on contextual relevance. So when I first read that, I just told myself, "Hey, what's that? I didn't got it. I have no idea what's that," because there are so many concepts related to this kind of database, this kind of model, that maybe should be interesting to talk about that. And then this is where this talk come from. So these talks come from this kind of the way that I decided to start to understand more about artificial intelligence, and it's go much more focused on how vector database works, and then brings a new insights about maybe a new search paradigm. So talking about that, when we talk about having a new search paradigm, it means that probably I don't know how much with you, but probably most of you, most of us have already been working with SQL database and NoSQL database. Has anyone worked with this kind of database here? Yeah, see, most of you for sure. So when we talk about this kind of database, they are not that simple, but they basically follow one concept. So you are working with columns, rows, and then you are able to make some kinds of pattern searching for them, and then you can retrieve what we're looking for. So, for example, when we talk about a database, a SQL or NoSQL database, we have some kinds of this database. For example, we have a key value database, for example, a Redis or a Postgres database, which you have a one key, and this key, when you search by it, you can retrieve some row from your database. Also, we have documents database, for example, a MongoDB database, or let's think about say the S3 from Amazon. Both of them are related to documents. Of course, not the same documents, but the concepts of having a document. And then once you have some kinds of key or a way to search, then you can get the documents. And also we have a graph database, which is under hoods of the NoSQL database, which relates to having your the connection between nodes using some leaves. So you are able to find your data using that. And when it's interesting because all of them they follow the same pattern for searching your results. So you will have one key, you have one string or one kinds of inputs that represents your key or what you want to search, and then you are able to search these kinds of value using a pattern matching between the results that you are getting. So this is how it works, and then it comes to the knowledge that there is something new, not really new, but I would say that in the past 8 years, vector database has been created, and the concepts of it has been growing, which is something different. So when you talk about vector database, it uses a vector search, which is basically transforming our data into a vector of numbers. And because of this vector of numbers, you are able to to find some 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 information that are relevant or closer to what you want. So what does that mean? So get this kind of example. Vector search uses two main concepts. One is the vector itself, and the other one is related to the dimensions that you are going to have in your database. Each dimension can have one meaning for your application, and under this dimension you will have some vectors that will be used to find the results that are closer to it. So for example, in this example here, which I got from the Weaviate blog, which is a really good vector database. If people would like to go to their blog, they have a lot of content that's that can help you to understand more about vector database and go deeper on it. So at this example, we basically have two two dimensions. One dimension that represents animals, and a second dimension that represents fruits. And for let's focus on the animal dimension. For the animal dimension, we have basically four different kinds of animals. So there is a wolf, a dog, a cat, and a queer kitten, and all of them they will be represented for a bunch of vectors with numbers, and this vector with numbers, when they are similar to each other, it means that they can be close to it. So let's think about a wolf. So a wolf and a dog, they are pretty close. I don't know if uh, anyone would not agree with that, but a wolf could be a dog, and a dog could be pretty similar to a dog, to a wolf. And when we represent this kind of data into vectors, the vector created, they will have a higher similarity between them. That's why they are pretty close on this graph. So this is how the vector search works. It works with retrieval research that finds results that are similar but not really equals. So it means that when we take a look at the SQL database, we need to find something that has the same pattern matching, so the same matching for our search. So you can find for a key, for a key that is 1, 2, or 3, and all the results that you look for it must have the 1, 2, and 3. When we talk about a vector search, it doesn't matter if it's equals, but it's matter if it's similar. So let's think that the wolf has, I don't know, maybe 10 different vectors to represent the wolf, and the dog also has 10 different vectors to represent the wolf. When we talk about, okay, I want to retrieve something similar to wolf, it doesn't mean that all the vectors from our result should be equals to the vector from the wolf. It means that they should be similar, and some of the similarities are based on some of the values of it. And just getting some real kinds of example, I just took this photo from, got this photo from the OCX Twitter, and it's from yesterday. So let's think about a real example here. So I have two photos here, and both of the photos are from OCX. How, if you do not use a vector database, how would you know that both of the photos are related to the same events, or both of the photos are represents a presentation in a conference? How would you do that? So one of the things that maybe people were doing that in the past were using tags. So in some place that you probably a SQL database or an NoSQL database, you are going to tag all your images with some information that correlates this image to something that will be used for search, and then you are able to retrieve that. But I don't know if anyone works with this kind of search, with image search. Anyone works with this kind of thing here? No? Okay. So if you are working with this kind of search, you might know that processing these images and creating all the tags for it is something that is not so easy. So let's think about that. At first, you just want to recognize if the images are from presentations in a conference, and then you place, I don't know, maybe 50 tags for it. And then after that, you want to now recognize if that image has any person on the image. And then to do that, you need to create some new tags and then process all the images that you have on your database, placing this new tag and so on. It's something that needs some effort to do that. And not only that, your search starts to get more and more slowly because of that, because you have new tags, you have more images, and then as more tags you have on your image, worse will be your search for that. Of course, you can have some indexing algorithm for that, but it's not trivial to do that. And then this is where come from the first thing that is related to vector search, which is how we can transform one image, one non-structured information into something that will be searchable into a vector database and be used into the vector search, which calls the embedding vectors. The embedding vectors is basically a list of numbers that can represent many types of data. So basically, that those images we are going to transform them into an embedding vectors, which is a list of numbers, a list of vectors that will represent that data. So just explaining better for it. So here I have one example that's that first image that I was showing. Let's think about that we are going to run all our images under one machine learning algorithm, and that machine learning will try to recognize all the things, all the patterns that we want to set up into an image. So, for example, you want to recognize all the images that represents the green color on in an image, or let's say let's run a machine learning algorithm that will try to find the pattern of how we represent a flower, or even the background. So when we process that, it will transform, it will convert your image, which was a flower image, into a vector of numbers, that will be used for the vector database. So basically, when we got that image, we just run one deep learning model or a machine learning model that will try to run some recognition from that image. So for example, if I want to recognize people in an image, or if I want to recognize if that image is an image from a presentation in a conference, that's the deep learning model will understand that. So you will need to train your deep learning to recognize that. And then once you have done that, you are able to transform your image into an embedding vectors. And these embedding vectors are the data that you are going to persist into your vector database and be used for the vector search. So not only think about image, but any kinds of non-structured data, we can do that. So we can have an audio and we can process one specific deep learning model for that audio. We can have one text, and that text we can also run a deep learning model under that text. We can have a video and run a deep learning model or a machine learning model to recognize the patterns of that video, and all of them we can convert into a vector embeddings. And as you can see, by the end we had different kinds of search. So we have one audio, a text, and a video. And once we run the deep learning models, now we have the same kinds of data, which is the vector embeddings. So now the contents of that audio, we can do the same search, and under that search, it can retrieve something related to a text or even related to a video. So by converting our search into a vector embeddings, we can transform it and make one search get some results from different kinds of data that we have in our application. And this is pretty awesome, because it might solve all the problems. So it's not only for no structured data. As you can see, I mentioned here that we can also run a deep learning model in a text, which is more structured data. So we can just process any kinds of information that we have on the internet. So when we think about that, more than 80% of the data in the internet are non-structured now, and it was difficult to make some search on them. Now, converting this kind of data into a vector embeddings, we are able to make a search in almost 100% of the data that we have in the internet. Here there is one link that refers to these kinds of search. So if you want to take a look at it, I strongly recommend. This is a pretty good link. It's from the MLOps community. So they are really focused on machine learning and some deep learning models that you can learn a lot of from them. And talking about embedding vectors, there are many players that you can use as a third-party application for that. You don't need to build your own deep learning model or your own machine learning algorithm to process your information and creating your embedding vectors. So you can use this third part. So there is Hugging Face, which can create an embedding vectors for you. If I'm not wrong, they are free, but they have a maximum use for the free license. So you can try that. There is also the OpenAI and Cohere, which are the most famous one. Both of them you can use them to create some embedding vectors with a limit access. So if I'm not wrong, Hugging Faces has a more limited free usage, and OpenAI, if you are already paying for the large language model plan, you can have embedding vectors on it, so you can also use that. And all of them you can use, and they have some APIs that you can connect your application to them, or using Java or Python, so you can use them. And just come back to the vector database. I we just talked about how we are going to transform or convert our data into something that's are searchable, and this is how the data vector database works. So a vector database basically uses the embedding vectors into it to get the results of your search. So a vector database is responsible to contains the algorithm that is used by the vector search to retrieve what are the embedding vectors related or the embedding vectors that are similar to what you are looking for. So the vector database has all the algorithm that you can find can that will know if the wolf and the dog embedding vectors are similar to each other, and then retrieve both of them when you are looking for a wolf, for example. Of course, it will not retrieve all the dogs, but some of them will be retrieved on your search. And talking about vector database, there are some vendors that I really like to use it. So there's Milvus, which is from the Linux Foundation, also an open source database. I really appreciate that it has a full playing ground that you can make that you can run some free examples, and you don't need to pay it. So for for the playing grounds, you have a full playing grounds with some tutorials, and you can learn a lot from it. I really appreciate that. It was the easiest one to be used when I was doing my research about that. Also, when we think about some database that are on the market for more time, they are starting to build some plugins for some extensions for vector database. So Neo4J, they build their own extension for vector database, and now you can use Neo4j and work with vector search and not only with graph database. So this is pretty awesome because it has all the flexibility to do that. And if you already have the know-how of how to maintain the infrastructure of Neo4j, this is one advantage because you are only need to install the new extension for it. I know, does anyone here works with Neo4j? Oh, there are some guys. That's good. So you have the chance to use vector database with Neo4j. It's pretty cool. I really appreciate that. I did some, not as many examples as I did with Milvus, but it was pretty easy to install the extension for vector search. So that's really good, and it's getting really good, pretty good results from it. Also, I mentioned before the Weaviate. It's a vector database. I really like it because not only because the vector database itself, but it's also about their blog. They have a lot of content related to vector database and vector search. If I'm not wrong, they have more than 3 benchmarks between other vector database. If you are interested about that, I totally recommend you to go there and take a look at it. And there are also other databases. So Pinecone is one of the, not the first, but it was one of the biggest biggest vector database in the past. So it was one of the database that just embraced the concept of vector search and helped to improve it by the time. With Quadrant, which was one of the first vector database released in the market. So both of them, they are good. They have a strong community behind them, and they are only focused on vector search. So they are not extensions. Also, I don't know anyone here is working with Postgres. Po- Yeah. So Postgres database also has their own extension for vector database for vector search. This is awesome because I personally I really like Postgres, and it was pretty interesting because when I started studying and work with vector database, they they didn't have this extension, so now they have it. So it's you can just try to do that. And as I mentioned before, if you are already working with Postgres, if you already have a team focused on providing the infrastructure for Postgres, you just need to install the extension for it. And there's Fice, which is a vector database. If I'm not wrong, it's from Facebook, so there is a big company behind it, and you can also use that. So just sharing some of the results here. It's a news from the posters extension. So I remember that they were still working on creating the extension, and they were getting some good results from it. And a month ago they released that they did some benchmarks comparing it with Pinecone, which was the first vector database. So they they showed pretty good results. So in this benchmark, I'm not sure if how was the benchmark. I took a read at it. I said, oh, that's good. That's pretty awesome. So it showed some better results that it's cheaper, and also Postgres is 100% open source, so you can go there and contribute for the community. And I believe that's all that I had. And for the last words, I'm, I'm a beginner at the artificial intelligence area. I don't know if anyone here is an expert at this area, but one thing that I would like to highlight here is that artificial intelligence is not only about large language models or, let's say, the RAG algorithms. I would say that it's a complete new ecosystem, and with a new ecosystem, new concepts and new technologies are just being created on it. And in my opinion, we could try to use them to solve other problems that we have in our area. So I totally recommend people to, hey, just go there and take a look how does an artificial intelligence application works, and if you could learn something from it. Actually, I remember maybe 12 years ago when no NoSQL database were starting to get some hype in the marketing. I had no idea what was that, and today, after I started working with NoSQL, I learned a lot, and some of the concepts that we have with SQL were just some barriers that I had to break, and now I have some new concepts of how we can work with data in the technology area. So I believe that with artificial intelligence is the same thing. We can also bring some concepts of it to other areas of technology. So that's all. Thank you for being here. I believe that we have some minutes for questions. So that's it. Anyone has any question about that? Oh, there's one question over there. Okay.
Hi, thanks. Maybe regarding the embeddings, when using any kind of vector database,
Okay.
closer, better? Okay. So when using any kind of vector database, you said, okay, you could use pre-trained embeddings or similar. Is there also the possibility to just use like a default embedding that is already shipped with the database or similar?
Yes, when you are using when you are using a vector database, the way that you create your embedding vectors, it's independent of your vector database. So you can have your own application that will create the embedding vectors, and then you can, for example, you can persist into one vector database, and if it's not good, you want to change the vendor, you can do it and then just migrate from one vector database to another. I would say that's the biggest difference between the vector database is related to the algorithm search. So some of them have some specifications on how they're going to index the vectors. They have some limitations in some algorithms. So this is what depends on your needs. You can find the best vector database for you.
All right, thanks.
So any other question? Maybe. Yeah. So I think that's all. So thank you all for that. Enjoy OCX experience. It's amazing. Thank you.